Hello friends, welcome back to our channel. So today we will see one more application of divide and conquer method, that is a binary search. And in today's session we will see an example for the binary search and then the algorithm, and finally we will see the time complexity. Right? So today's concept is a binary search. So search means searching or finding an element whether it is present in the given list of elements or not. So if it is there, automatically will return that element or a position, or we can say that element is found in the list. Otherwise we will say it is not found. And in order to solve this one, we are going to use this divide and conquer. That means we are going to divide the complete list into two halves, and we are going to solve the problem by selecting either one of the half, right? So every time we are going to reduce the search space. For example, if a list contains some 5 elements or 6 elements, in the second, after first iteration, after dividing the list, so then the search space will be reduced to around 3 elements or 2 elements. So like this, we are going to reduce the search space after every iteration until it gets only one element. Okay, so let us consider an example first. First, let us see the procedure, how we are going to solve that one, and then we will move on with the algorithm and then a time complexity. Now, consider a list of elements, and one first thing, very important, if you want to perform this binary search, make sure that the element should be in a sorted order. That is a one important constraint before starting this binary search procedure, right? So very important. So elements should be in sorted order. So this is important for binary search. And if you are moving with another one, linear search, so there will be no constraints. The elements can be of any order, so that we can find the element, that we can perform the linear search. But coming to the binary search, make sure that the element should be in a sorted order before starting the binary search. Now consider an example. So we are going to take some sorted elements. So I take it 10, 15, 35, 42, 58. So I'll take a small elements, okay, only 5 elements. So here I am considering 5 elements. So now consider this one as a low, this one as a high. Okay, low and high. First we need to find out the middle element. Okay, middle. So consider the index values 0, 1, 2, 3, 4, and this is the 5 elements. These are the 5 elements. And now we need to know the key value, that means the search key. So which element we are going to find. Let it be the search value is 10. Search value is 10. Now in the first step, find out the middle value. So mid is equal to, so low plus high divided by 2. So which gives, so 0 plus 4 divided by 2 is equal to 2. So middle is a 2. Okay, middle is 2. So what we have to check, see, the low is a starting element and high is the last element. Okay, low is the starting element, high is the last element. So always we know that low will be less than high. We know the process, right? So always low will be less than or equal to high. because if the elements are only one element, the same element will be pointing towards the low and high. So low is less than or equal to high. And if low is greater than high, then such is not possible. Or we can say that element is not found. Okay, if low is greater than high, then such will be not possible, right? So we need to repeat the same process. Okay, we need to repeat the middle, calculating the mid value until the low becomes greater than high. Now see, middle. Now what is the element of a middle, right? This one is a mid. This one is the mid. Okay, so now compare the middle element with the search element. Compare middle element with the search element. So I need to compare search element, and let it be, the name of array is capital A. So A of mid. So we need to compare this one, right? So what happens? K is a 10 is equal to 35. Is it true or not? If it is true, that implies our search value is equal to the low of mid, A of mid. So obviously we can say that the element is found in the list. So if it is false, check 10 is less than 5 or 10 is greater than 5. First let us take the greater than, because it's a false condition. So 10 is a greater than 35. That means we are comparing the search with middle element. This is the middle element, right? So 10 is greater than 35. So it is false. Next, 10 is less than 35. So if you want to compare two values, only these three are possible. Whether either both are equal, either the first element is less than the second element, or either first element will be greater than the second element. Only the three possibilities. Now check, 10 is less than 35. Yes, this is true. What happens? That what says this one means search element is less than 35, and the constraint is elements should be in a sorted order, and from this point 10 is less than 35. Obviously that implies the search element may be less than the middle element, less than the portion of middle element. Okay, I hope you understood. So here from low to high we are finding the middle value, and in the middle value we are checking and comparison. So we are comparing the middle element, and based upon this one we are selecting either we have to choose the left portion of the middle or right portion of the middle. And here 10 less than high, okay, 10 less than 35, it is true. Then we have to select the left portion, because all the elements which are less than 35 will be towards the left side of the elements. Now what we have to do? We have to change the search space, and here the search space is low to high, and now the search space will be low to, and already we have compared this middle element, right? Here we have compared the middle element. So the search space will be reduced to mid minus 1. Mid minus 1. Okay, mid minus 1. For example, if the search element, if the key is some 42, what happens? So up to this one, the same procedure. So 42 is equal to 35. Wrong. 42 greater than 35. True. That means whatever the element we are going to search, that is on right side portion because of this sorted order. So what happens? So the portion, the search space will be reduced towards the right side portion. What is the right side portion? Already the middle element has been compared. So we need to change the low value. So low value, so the search space will be mid plus 1 to high. mid plus 1 to high. So we need to search only this portion. If it is less than this portion. Okay. So like this we have to repeat and we have to check and we have to stop this procedure whenever the low is greater than high. If the element is not found, automatically we will get the low greater than high. So then we have to stop this procedure. And see, so we are performing the division operation and one comparison. Division operation and one comparison. Right. See, we'll check. Now you can see 10 less than 35, then it is low to mid minus 1. And now the elements are, so 10 and 15. And we should not consider 35. Mid minus 1 means here low 0, mid minus 1, 2 minus 1 is 1. So the search space is reduced to index values from 0 to 1 and here also 0 to 1. And you can see this one will be 0, this one will be 1 and we need to find out again a mid value. So this will be a low value and repeat the same process which we have done is the same, right? So again calculate a mid is equal to low plus high divided by 2 which gives 0 plus 1 divided by 2 is equal to 0. So compare key value and 10, key value and A of mid. So which gives key value is 10, middle value and A of 0, that means A of 0 is 10, 10 is equal to 10. So obviously we found the element. If it is not found, again we have to repeat the same process. Okay, so hope you understood. So first the search space will be from low to high, and if after the first iteration, that means after finding the first middle element, we are based upon the middle element comparison, we are reducing the search space from either left portion or the right portion. If it is a left portion, the range will be from 0 to mid minus 1, and if it is the right portion, the range the search space will be from mid plus 1 to high, and we have to repeat the same process. Okay, now we'll write the algorithm. Recursive algorithm, right? We can write the recursive algorithm. So I'll write here. It's a very simple algorithm. Binary search. So we can take a lot of parameters, like array. We can pass the array, low, high and key. So I will take it as some array, low, high, key. So we need to follow this order. First one is an array, second one is a low, third one is a high, and fourth one is a key. Now first we have to find whether low is less than or equal to high, and if it is low is greater than high, then simply we can say it is not possible. So if low greater than high, so we can simply return false. We can write return false or element not found, whatever it may be, based upon our logic, based upon our presentation, we can write it. And else, that means if low is not less than, low is not greater than high, next we have to find out the procedure. What we have to do? First we have to calculate the middle value. So middle value is equal to, so the same thing, low plus high divided by 2. So after getting the mid value, this is an index, right? Now we have to compare middle the key with the middle element. So here, if mid is equal to some array of, if key is equal to array of mid, then write down return true. return true, or you can write it yes, the element found at the position mid. Mid is the position, right? Else, again we have to check the condition. Else if key is less than array of mid, what happens? If that search element is less than the middle element, obviously the search space will be left hand side. So what left hand side, what we have to do on the left hand side means the search space will be reduced. So low will be remain same and high becomes mid minus 1. So you can write it the recursive call. So we can simply call the same thing. So binary search, what we have to do, so first one is array, low value is same and the high value will be mid minus 1 and a key. Okay, then else if both the cases are false, that implies the key is greater than array of mid. So again we can write binary search, and now also array, the search space will be now reduced to right half. Right half means low value will be changed to mid plus 1. So mid plus 1 to high key. So this is a simple and very easy algorithm. So everything is, the complete problem will be divided, and based upon the division, based upon the comparison, we have to change the search space. Search space means from where to where, either low is changed or high is changed. So we have to repeat the same process until the low value is greater than high. So if this problem came low greater than high, that implies the element is not found in the array. Okay, so now we will see the time complexity. Hope this is very simple. So hope you understood this one. Now we will go with the time complexity. What is the time complexity? So the best case time complexity is order of 1, because if you are searching the search element is the middle element. For example, if key is equal to 35, how many comparisons do you require? So here in this case, that is the middle element. Obviously in the first comparison itself we will get the search. Okay, so it will be order of 1. It's a best case, and always we have to consider the worst case, right? So consider the worst case. So T of n is equal to, what we are doing? We are dividing and we are doing the comparison. So what we have to do? T of n divided by 2 plus 1. So we are not solving two portions. Okay, we are solving only one portion, either left half or right half. So that's why I am writing only one time, T of n by 2. And after that we are comparing, one comparison. And see, we need to find out the n, what is n, and see, in the first step we are finding n divided by 2. Okay, so in the next step we are finding n divided by 4. See, now we are checking n divided by 2, that becomes n divided by 4 plus 1 plus 1. And again we are performing the same thing in the next half. So n by 4 half, that means n by 8 plus 1 plus 1 plus 1. And similarly T of n by 16 plus 1 plus 1 plus 1 plus 1. So what happens? Every time we are dividing the search space into half. So first we are having some 5 elements. From that we are dividing the 5 to 2, and then we are dividing the 2 to 1. Okay, so we are keep on repeating the same process until we get the element, only one element. So you can simply say that this is T of n by 2 power k plus k terms. Okay, now when we have to stop, so that is also most important here, stop condition. So when we are going to stop this division, so n by 2 power k is equal to 1 element. So we are keep on repeatedly dividing the complete list, and we are stopping whenever n divided by 2k becomes 1 element. Okay, so from this equation we can say n is equal to 2 power k. So substitute the same thing here. So what happens here? So the same process will be repeated, and t of n by 2k is n plus, from this one, what is the k value? So log n base 2. So we can represent it as log n base 2. Okay, now what happens is equal to t of 1 plus log n base 2. So if there is only one element, then automatically it will be 1. So 1 plus log n base 2. So the time complexity, we can say the time complexity is equal to order of log n base 2. So this is the time complexity for binary search. Okay, using divide and conquer. So here we are not combining all the solutions. So just we are dividing the complete problem into sub problems, and we are considering only one portion, not the two portions, and we are repeating the same process until it reaches to one element, and we are comparing, and if it is not found, we are saying that element is not available. So the only one constraint here is elements, all the elements should be in a sorted order. So that is the most important constraints we have to follow while starting this binary search process, right? So let's stop here, and hope you understood this binary search. We have seen the complete example with the small elements, and so try with the more number of elements. Consider some 10 elements and try out with all the possibilities, left half, right half, and no element. Okay, so hope you understood and enjoyed, and if you are having any doubts regarding this binary search, so feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.